Hello everyone, this is Mr. Hussein Mosabi. So in this video, we'll be basically just solving some questions that are found in Mulungushi University Theory Sheets. And this is basically Theory Sheet 2 on vectors. The simple question, just question 6, having some vector problems. So anyway, let's get to it. So it says that the helicopter view in the figure, as you can see, this is the figure we're looking at here. It shows two people pulling on a stubborn mule. Yeah, as you can see, this guy is the mule and these two are the people. Alright, so now they're asking us to find the single force that is equivalent to the two forces that are pulling. Okay, and then to find the third force, and to find the force, a third person would have to exert on the mule to make the net force equal to 0. The force are measured in units, which are basically newtons, like we all know. So anyway, let's start with A. So in order for us to solve A, it's quite simple. There are about 2 ways we can solve this. So we'll start with method 1. So now this equivalent force that they're looking for is what we call the resultant force. Okay, the resultant force is simply a single force that represents two or more forces acting at a particular point or acting on a system. So we'll have the Cartesian method and basically the graphical method. So using the Cartesian method, which would be the method 1, using the first method, all we have to do is to find the components of each force. So this first force, we find the component. So let's start with force 1. What components does it have? So first, look for the size of force 1. Force 1 has the size of what? So size is equal to what? 120 newtons. And you need the direction, which is theta. Now, every time you're using the Cartesian, always measure your direction from the positive x-axis. This is the positive x-axis. So from this axis going this way, what angle is here? That's what we're interested in. So that's what we mean. So from the positive x-axis, this is force 1, measure from the positive x-axis. So from the positive x-axis until you touch the first force, which is force 1, what angle is this? As you can see, it has been given here to be what? 60 degrees. And the moment you do that, all you have to do is to find the components of F1. So you first find the x component of the first F1 force. So you say F1x, which is the x component, will always be size. Remember, for the x, size cos direction. So this will simply just be size, which is 120, cos direction, which is 60 degrees. And if you compute this, just write F1x. If you compute this using a calculator, say 120 times cos 60, you get a 60. So you get 60 newtons. So that is the x component of force 1. So let's look for the y component. So the x component, look for the y component. F1y is equal to the size. Now for the y component, remember it's size sine what? Theta. So F1y is equal to size, which is 120, sine, which is times sine, theta, which is 60 degrees. If you compute this, F1y, if you compute this, you have 120 times sine 60, which will give you about a 60√3 newtons. You can write, others would prefer to write 103.92 newtons. So either ways, you can pick any one of the two and you'll still be fine. So basically that's what you have to do. So now these are the components of the first force that you have. So now what you have to do is to look for the components of the other force. Let me just use red for explanation purposes. So to find these other components of force 2, so this is the force I'm talking about. So for force 2, we're looking for first let's look for the size. What size is this? Size has been given, which is what? 80 newtons. What is the direction? We need the direction. In life, you must have direction. So remember, the direction is measured from the positive x-axis. So from the positive x-axis here until we touch the line of this what? Vector that we have. So again, let's do that. From that till we touch this line, isn't it? because that is force 2 that we're interested in. Now what size is this? What size is this? That is something that you need to know. Now remember that here you're having 90 degrees here. You get the point, right? So basically you need to find the angle that is here, because you know, okay, from this point going downwards, this is what, 90 degrees. So we're going to say, okay, what is 90 plus this angle here that we don't know? So let's find that angle that we don't know. So this angle is what we want to find. So what angle is this? What angle is this, first of all? So you know that this is the entire line here will give you 90. So you're just going to say, okay, this is going to be x plus 75 should give me what, 90. So it's going to be x equal to 90 minus what, 75, and that angle there will just be 90 minus what, 75, which will be 15 degrees. So that is the angle that is here. So you need to now use this same angle that you have found plus this 90 degrees, because you know from here to there it's 90 degrees. So you want from here all the way, not stopping here because that's where 90 starts. So from here, this line from there to there is 90 plus this angle here. What are you going to have? That will be your direction, because the direction is always measured from the positive x-axis whenever you're using the Cartesian method. It's going to be 90 plus what, 15. And then if you compute that 90 plus 15, basically that's just a no-brainer. It's simply just 105. Then remember, find out components. So you say f2x is going to be what? Remember, it is size. We're using this size cos what? The angle, which is the direction. Size is 80 times cos direction, which is 105. Choose the calculator here. Say what is 80 times cos 105? What are you going to be having there? Alright, so 80 times cos 105, you'll be having f2x to be equivalent to minus 20.71 newtons. I've just rounded it off. Then again, you will now find f, this is the x component, then find the y component, which is going to be f2y, which is equivalent to, it's going to be now 80 times sine 105. And this will be what if you compute it? If you compute this, you'll be having 80 times sine 105. Basically, that will give you 77.27 newtons. So you're having the components of all the forces. So now all you have to do now is simply just to sum up the x components. So now you need to find the magnitude, which is the size of this resultant force. So the resultant force R is equal to the root of the summation of the fx component squared plus the summation of the fy component squared, all the x components that you have. So you're going to add up all the x components. So you're going to say, okay, my resultant is equal to the root of, what are the x components that you have? Add all the x components. You have 60, then you have this other one, which is so it's going to be plus minus 20.71, because now if you add this plus a negative, it's going to be plus minus 20.71, then this will be squared plus all the y components, which will be let me use this one here. It's going to be 103.92 plus 77.27 squared. So if you compute this on your calculator, you find the value of basically what you have, which is 60 minus 20.71. That value that you have, you square it and you say plus, okay, 103.92 plus 77.27, and you square it. Then what you're going to be having is your interest. So in this case, we're having our resultant to be 185.4009714. Therefore, our resultant will be 185.4 newtons, and that will be our answer. So basically, this is just one of the methods that we apply when finding the result. The resultant force, which is a single force that is equivalent to whatever number of forces that will be acting on the system. So be mindful of that. Step 1, resolve all the forces into their x and y components, and by doing that, all you have to remember is the f, the size cos theta for the x component, and the size sine theta for the what? Y components. Then just remember that all the directions should be taken from the what? Positive x-axis. Positive x-axis. So if you have that, whatever force is there and there, take the direction from the positive x-axis. This will be the one for F1. Okay, and then the other one will be from there, whatever size that you have here will be theta 2 for F2. Be mindful about this. Then remember that the straight line will always adapt to what? 180. Then the straight y-axis line divides it into 90, even the other side what? 90, which sums this to what? 180. Now let's quickly look at method 2 of question what? 6a. We'll do b separately. Alright, so let's move. So let's apply a different method. So this different method works like this. So the whole goal that you have to do is to find the steps actually. Step 1, just simply find the forces. So let me just say the forces. Find the angle, which is the direction between the two forces. Between the two forces that you have. This method only works for two forces acting on a system. So find the direction between the two forces. Yeah, I'm only saying this works for two forces because it's going to be a bit complex if we had more than two forces and we try to use this method. So basically, I would advise you only use this method when you have two forces. Yeah, so find the angle that's between the two forces. So you see this is force 1 and force 2. So let's find the angle in between, which is this one here. So now what would be this angle in between? Basically, if you look here, you're having 60 and what? 70. And you know a straight line adds up to what? 180. So you're going to say, okay, this angle is going to be 75 plus 60 plus theta should give me what? 180 degrees. So if you add this, it's okay. 75 plus 60. What am I going to have? You're going to have 135 plus theta is equal to what? 180. So for theta is equal to 180 minus 135. So theta is equal to 180 minus 135. Basically, that will give you what? 45 degrees. Just like that. Then you found the angle that you're interested in. But anyway, this is something that is simple. Alright, so once you find the angle that is in between the two forces, all you have to do is to follow step 2, which says draw a parallelogram. Okay, so basically you don't really need to have a ruler or dimensions to draw this parallelogram. Doesn't really matter. You can just draw any rough parallelogram so long as it's a parallelogram. Remember, a parallelogram will have, let me just draw it so you can easily remember it. Use a different color for this. Use blue. So this is my parallelogram. So every time you have a parallelogram, the only thing that you need to do is to pick the point of interest, the center point. This point here is our point that I'm talking about. So I can use this point. I can call this point to be. Let me call this point. Let me call it point H because my name is Hussein. All right, so point H. So basically, point H has the angle in between. So which means if this is point H, this line going this side and this side will represent the two forces that you had. So this means that I can call this line going this side to be my force 2. So I can get, okay, this is force 2, which means automatically this becomes what? Force 1. And in between you have what? The angle that you found, which is 45 degrees. You see? Yes. So now I want to be putting F2. Let me put the values of F2 and F1. So F2 is what? F2 is 80 degrees. So not 80 degrees, 80 newtons. Then F1 is 120. Then the angle we have is what? 45. Remember, if it's a parallelogram, if this is 45, even this is what? 45. So let's do this, change the color. So if this is 45, even this is what? 45 degrees. And if this is 80, even this is what? 80. If this is 120, even this is what? 120. But one thing you should know is that the parallelogram always add up to what? 360 degrees. So you need to know what these other what? Angles are. So let's try and find them. So I'm going to say x plus 45 plus 45 should give me what? 360. Basically, you know 45 plus 45 is what? Yes. 90. So we're going to have 2x plus 90 is equal to what? 360. So 2x is equal to 360 minus 90. Yes, okay. So what is 360 minus 90? I see a hand. Okay, who is that? Is that you, Jennifer? Okay, it's not already Jennifer, but I know you know the answer. It's going to give you what? 270. So divide by 2, divide by 2. So what would be the answer if you divide 270 by 2? You have 135 degrees. So now this 135 degrees that were found is basically for x. This is 135 and this is 135. So now the moment you draw up a parallelogram, all you have to do is to find all the angles and all the side values that you have, like we have done here. So the moment we do this, we can now move on to step 3. Step 3, draw a line from the center. By the center, I'm talking about that point that you chose to be H. That was, showing you which one was F1 and F2. So draw a line from, let me just say H in this case, that cuts the angles. That cuts, say the angles. So some angles. Say angles like that. So pick different color. Let me try. What color can we try? Let's try black. So from this I cut. So it's cutting some angles, you see. So remember that the angles cut shouldn't be considered. Be mindful of that. Alright, so now you'll be having two shapes, shape A and shape what? B. From there, pick any shape. Pick any shape. Once you pick any shape, this line that you just drew is a resultant. Once you pick the shape, solve for R using what? Cosine rule. You learned this in grade 12, as most lecturers will tell you. But basically, yeah, it's actually true, you did learn it in grade 12. So I pick shape A. So shape A looks something like this. So you have 120, you have 80, you have these points. And remember, we're not considering the angles 45 that has been cut. So we're going to consider this angle, which is 135 degrees. Alright. With this, we can now apply the cosine rule. So the cosine rule states that if you want to find R, given two sides and an angle in between, use the cosine rule. The formula will be the root of all the sides given, that is 120 squared plus 80 squared. Sorry about that, it's going to be minus 2, 120, 80 times cos theta, which is the angle that is in between, which is 135 degrees. So basically all you have to do is to get your wonderful calculators that you have and basically just try and punch these things and see how life goes for you, because this cosine thing is something that we all know. So if you try and punch this, what are you going to be having? Yeah, so let's try punching this and see what you have in the end. Yep, very important. Okay, so let's do 120 times 80 times cos 135. Shift, not even shifting anything. Alright, so if you just punch this, you have 185.40887 newtons, because it's actually the resultant force and it's actually a newton. So newtons. Therefore, I can just round this off to 185.4 newtons, like that. So I'm glad you got the hang of it. So if you look at this answer here versus this answer here, you'd find that it's basically the same. So these are just the two methods you can use. You can pick whichever you feel like you're comfortable with. So this is how you find a resultant force given two forces acting in a particular system using the graphical method and the Cartesian method. My name is Mr. Hussein Mwasapi. Don't forget to like and subscribe to my channel, and remember, it is very important to strategize before you become a statistic, and always try to push for that A+.